We're going to measure and calculate the height of our rockets. Now, it's not a good idea for us to take a tape measure and take it to our rocket and launch it. It's a good way for your rocket to come back right at you. Okay? So, what we're going to do is we're going to use a little bit of math. So first, our rocket will be right here on the launch pad. Okay? And then we'll be standing a safe distance over here at A. Now, when it's your rocket, you'll have the control pad and you're the one that will launch it. Then you guys will use this. You'll take turns with a partner. And you see these two triangles here?
Yes.
These are like sights. So you'll keep them lined up and follow the rocket up in the air. Alright? So as it gets up here to its maximum height, what's that new word that we just learned in that reading for maximum height?
Tangent.
No, not tangent. Raise your hand. Ready? Thank you for raising your hand. What? Apogee. Up here at its maximum height, at the apogee, like you know how when you guys are like on a swing, you know how when you get to the highs that you're going, it kind of pauses for a second?
Yeah.
That's what our rocket's going to do. So, you'll just follow it up, and whenever it stops going up and it kind of freezes, you'll freeze. Make sure you keep them on, and then you'll have your partner read off what degree it is. It'll say 50 degrees. Alright? So, this angle is 50 degrees. So, we've got all we need to do the math to figure out how high our rocket went. Now, I learned this in my college algebra class. Before I went to Marshall, I did 1 year WUP. I'm Professor Cunningham. I remember him teaching us this about tangents, as well as there's some other things that go along with tangents. Cosine and sine go along with tangents, and you use these to get different measurements of angles. And I remember thinking, I am never going to use this. Why am I learning this? But there's something very, very important that I was working on at that time. So at that time, me and my friends were very much into the extreme sport of paintball. And so that's what I was working on during this time. When I was staying there during the day, after I finished my homework, maybe sometimes before I didn't even finish it, I would work on plans for the paintball tank. Well, it was like the same week that Professor Cunningham was teaching us this with triangles and such, that I needed to use the same information to get my measurements right for some of the supports on the frame of my paintball tank. Now, there's other ways you can use this. I mean, not all of you guys are going to build paintball tanks, but if you're into building anything, construction, welding, anything like that, or carpentry, woodworking, you'll need to use these at some point, most likely. Okay? And it's honestly really simple, because after we have these, we'll have 2 more steps, really. So first, if you look down here at this table, we need to find the tangent for 50 degrees. Alright? So if you look, I have multiple columns here. We find 50 degrees. See it right here? So 1.19. And so then what we do, 1.19, that is our tangent for 50 degrees. And we multiply it by our baseline distance. Okay? That's how far we are away from the rocket. 150 feet. And this will give us our height. So I'm going to put h equals, meaning height equals. So, what is that? Height equals what, Bertie? 178.5. 178.5 what? Chalupas, chinchillas, hamsters, what? Feet.